Faradays and Lenzs laws B. The figure shows a wire carrying a constant current as well as a conducting loop in the vicinity of the wire. In which direction, if any, will there be a current in the loop if the loop starts at the first symbol listed and ends at the second one? Circle the answer. These symbols are locations in space, and we're starting the loop at one location and we're ending the loop at the other location. And the question is, in what direction will there be a current in this conducting loop if you start it there and end it there? Well, let's start easy. Isn't it true that if we have position percentage and $, if you start at one and end at the other, the flux, and on this side of the page, isn't the flux going to be the magnetic field is directed into the page over here? And up here, by the thumb can twist and right hand rule, point your right thumb, and my fingers above the wire are coming out towards us, and down below, my fingers are going into the page. That's the direction of the magnetic field above and below this wire. But for percentage and $, or $, to percentage, the amount of flux won't be changing because the strength of the field is going to be the same at those locations and the area is the same. I'm thinking $, and percentage, no induced. Is there a percentage in $? Letter F, no induced. Similarly, how about this pound key and the and symbol? Same sort of thing. Do we have any of those? We do. Pound symbol and symbol, no induced EMF. Is there another one? And symbol, letter H. See that? And symbol and pound, no induced EMF. Okay, so we got 4 of the 8. What's the next one? We're going to start at asterisk, and we're going to go to and. So where is that? Asterisk is right up here, and is right here. So if you start here and end here, remember that as you get closer to the wire, the field gets stronger. If I put a bunch of field lines right there, but as we get further away, the field gets weaker. So if we start at asterisk and we go to the and symbol, you can see that the flux out of the page is increasing. And what does Lenz's law say? If the flux out of the page is increasing, I don't like a change in flux. So I'm going to use my thumb. I'm going to fight that out of the page change. Whoop, clockwise. I'm thinking clockwise right there. How about from $, to the ampersand symbol? $, ampersand. Okay, so same thing down here. Close to the wire, the field is strong. I'm going to put quite a few X's. As we get further away, the field gets weaker. We start at $, and go to this little at symbol, then the flux out of the page is decreasing. What does Lenz's law say? I don't like a change. I don't like the flux. Sorry, the flux into the page is decreasing. I don't like flux into the page decreasing. I'm going to use my thumb and I'm going to try to help. Clockwise. A couple more. The and symbol to the asterisk. The and symbol right there. We've got flux coming out of the page at us, and as we move it up here, it's coming out of the page, but it's less. Lenz's law says, oh, I don't like the fact that it's coming out of the page being less. I'm going to use my thumb, and I'm going to try and help. Counterclockwise. Last one. The at symbol to the $. Right here at the at symbol, we have into the page flux, but not very much. When we get to the $, we have into the page flux and more into the page flux. Lenz's law says, I don't like that change. I'm going to fight that into the page flux with my thumb to try and resist that. Counterclockwise.